Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of InnoEnergy. Remember that this biomass energy course has 9 lessons. Lesson 4 is about the biomass supply chain. A supply chain is a system of organizations, people, activities, information, and resources involved in moving a product or service from supplier to customer. They are linked by materials, cash flows, and information. It is important to note that while materials and payments are unidirectional, information flows are bidirectional. A biomass supply chain covers from the production of feedstocks to the supply of energy to the end user. It is usually more complex than those of other resources of energy, like natural gas or solar photovoltaics. There are many potential configurations of bioenergy supply chains, also known as bioenergy pathways. Let's see some examples. The source of biomass can be diverse, from agricultural business to forest management. These sources generate different types of feedstock, which can be processed to produce heat, electricity, or biofuels. Heat and electricity can be used in different applications that provide services to several sectors. A pathway connects several of these items. Many biomass supply chains have proven to be economically viable and are considered sustainable, others not. The viability of a supply chain can change over time due to, for instance, technological improvements or fluctuations in operational costs. The objective of this video is not to define a supply chain, but to help students at master level to define a supply chain for a biomass to energy system and to identify the critical parts. We recommend watching the videos about biomass resources and about the technology development status to better understand the details of the production of biomass and its transformation into energy. We will analyze the following topics. What are the stages in a biomass supply chain? What is supply chain management? What are the factors that influence biomass fuel costs? And what are the critical factors for optimization? Let's start with the stages in a biomass supply chain. Start thinking on the biomass production. What is the origin of the organic matter? Forestry? Agricultural residues? Energy crops? The second stage is harvesting. Harvesting is the process of collecting crops from fields or wood from forests and gardens. The third stage can be the transformation into biofuels. It can be done on-site or it can be done in a transformation center. It is important to establish where and how the biomass will be dried. Now, it is time to think about logistics. That is, the flow of materials or products between the point of origin and the point of consumption to meet requirements of customers. Transportation steps depend on how and where the biomass is processed. Depending on the type of biomass or biofuel, you should add a plant for the further transformation into pellets or torrefied chips or pellets. Once the biomass is ready, the next step shall be to define how it will be commercialized and sold to the consumers. The process of conversion of biomass into useful energy, for example heat and/or electricity, requires the supply of biomass fuel as well as conversion equipment, typically boilers, gasifiers, digesters, and/or engines. Finally, define how the useful energy will be distributed and commercialized to end users. Once you have defined your supply chain, you must decide how to manage it. The management of the supply chain in any biomass-based project is nothing less than a great management challenge. The complexity deepens due to the large number of stages and actors that encompass the entire biomass value chain. Let's choose a single option for each stage. Understanding the actors involved, their needs and interests is key to assess the viability of a given supply chain. You must analyze who is involved in each stage, from the management of natural resources to the management of energy commercialization. After that, you must analyze what are the factors that influence biomass fuel costs. Production costs depend strongly on the source of the biomass. For forestry biomass, think about the costs of forest management and replantation. The costs of timber or residues production and handling and transportation from the forest to the distribution or transformation centers. For agricultural residues, costs depend strongly on how residues are collected and processed. For energy crops, the plantation and management of crops must be included. Biomass requires a process of pre-treatment, including drying or transformation. The way on how this is done strongly influences costs. However, increasing the quality also increases the market value. Biomass requires larger means of logistics than other fuels and feedstocks because its voluminous nature and its low energy density. That implies more workforce, better storage infrastructure, and higher transportation costs. Finally, biomass can summit to further transformation. This increases costs, but also quality and price. This table shows the costs in US dollars per gigajoule of energy for the different stages. Production costs are in general very low. There is a wide range of cost for the collection stage. The highest costs are for fuel wood. Transport to the end user can represent a high percentage of the final costs for residues. After defining the supply chain for your project, you must identify the critical points. Which stages can produce a shortage in the supply? Which stages are incurring in more costs? Look for the supply chain stages that can be optimized. We have seen that collection and transportation to the end user are the stages with higher costs. Let's focus on them. Regardless of its origin, the relative cost of biomass collection will be considerable. Operations can be energy and labor intensive. The use of machinery reduces costs. However, it cannot be enough. Careful development of a system to minimize machinery use, human effort, and energy inputs can have a considerable impact on the cost of the biomass as delivered to the processing plant gate. Key components to reduce costs can be summarized as: reduce the number of harvesting operations and introduce advanced technologies. Increase the bulk density of biomass. Transform it into easy-to-handle shapes. Work with minimal moisture content. Reduce the transportation distances. Logistics is a key part of the supply chain that is often overlooked by project developers. It includes the transport, handling, and storage of the bulky and variable biomass material for delivery to the biomass plant. The biomass supply must guarantee sufficient feedstock throughout the year to avoid shortages. Supplying from different sources reduces the risk of shortages. However, it complicates supply logistics. This strategy must also guarantee quality specifications of feedstock. Determining storage capacity and its specifications should be part of the supply chain design due to its influence on supply costs. Think about using biomass logistic and trade centers to optimize your biomass supply chain. Think also about the storage at the energy plant needed to guarantee continuous supply and the associated costs. Keeping a lower inventory level at the end user storage will probably shift the need for inventory storage to the suppliers, eventually leading to higher biomass supply costs. That can represent a higher cost of energy for the end user. Wrapping up, a biomass supply chain covers from the production of feedstocks to the supply of energy to the end user. It is usually complex and includes many stages. This allows for many different configurations, and it involves many actors with different needs and interests. An accurate design and management is needed to reach cost-effective production and commercialization of biomass feedstocks.